Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe.
Hello future engineers, here is another video in Engineers in Progress, particularly on the topic on area by coordinates and angle formed between two lines. I hope that this video will thereby improve your skills, analytical skills, especially in computing areas bounded by regions, and the technique in computing angles without formulas, just based on the slope. And allow me to present the solutions in a manner with less animations so that I can finish this in just considerable while. This is problem 40. Find the area bounded by the points 3, negative 1, negative 1, negative 4, 2, 5, and 6, negative 2. Also locate the centroid and determine the vertex angles. Um, Take note that the area to be used is 1/2. Then instead of brackets, I use absolute value bars so that when the points are arranged wrongly, the correct arrangement should be in counterclockwise manners. If you arrange them in clockwise manners, the area would be negative. But as long as you compute it correctly, you just make it positive if you arrange the points in clockwise manner. So the absolute value bars will let you recall that the points should be arranged in counterclockwise manner. So 3 comma negative 4 is this point, 3 comma negative 1 rather is this point. The next is negative 1 comma negative 4, that would be clockwise arrangement. So I arrange the points in counterclockwise manner. So 3 comma negative 1, if this is the beginning point, you can start anywhere at any point as long as the arrangement is counterclockwise. So next point should be 6 comma negative 2, then 2 comma 5, then negative 1 comma negative 4. Then don't forget to go back to the original starting point, which is 3 comma negative 1. So without memorizing the formula, all you have to do is imagine that this region is enclosed with a rectangle. Then we subtract areas which can be computed, like uh, right triangles. Right triangles, we have rectangle, then another right triangle. So for the distance, for instance, horizontal distance, it should be right x coordinate, so 6 minus left x coordinate 2, so that's why this is 4. The vertical distance is upper y coordinate 5 minus negative 2, so that's why we have 7 here. The area is 1/2 of 4 times 7, so 1/2 of 28 is 14. For this right triangle, 1/2 of by the way, the horizontal distance is right x 2 minus negative 1, so we have 3 units. And vertical distance upper y 5 minus lower y negative 4, so we have 9 units. The area is 1/2 of 3 times 9, 1/2 of 27 is 13.5 square units. Then this right triangle, upper y negative 1 minus lower y negative 4, so positive 3. Then the horizontal distance, right x 3 minus left x negative 1, so 4 units. The area is 1/2 of 3 times 4, so the area is in box 6. Then we have here this right triangle. The horizontal distance is right x6 minus 3, so 3. The vertical distance is 1. Negative 1 minus negative 2, so 1. So the area is 1/2 of 3 times 1, so 1.5 square units. Then finally, this rectangle, this vertical distance is negative 2 minus negative 4, so positive 2. The area is, this is a rectangle, so 3 times 2, so 6. Then, by area by coordinates, so we have area is 1/2, so beginning with 3 comma negative 1 in counterclockwise direction. So this would be the arrangements. So we have 1/2 of 3 times negative 2, so 1/2 of negative 6, 6 times 5, positive 30, 2 times negative 4, negative 8, negative 1 times negative 1 is positive 1, minus quantity, negative 1 times 6, negative 6, negative 2 times 2, negative 4, 5 times negative 1, negative 5, then negative 4 times 3, negative 12. So negative 12, negative 17, negative 21, negative 27 times negative positive 27, 28 minus 8, 20 plus 30, 50, 50 minus 6 is 44, then 1/2 of 44 is 22 square units. So that's the area. Another way, without formula, the rectangle, imaginary rectangle circumscribing the region is 4 plus 3, 7 by 9. So 7 times 9 minus this area 1.5 minus this area of rectangle 6 minus this area which is another 6, then minus 14 minus 13.5. So the area is also 22 square units. Then we divide to locate the centroid, we divide the figure into two triangles. So into two triangles, that's the rectangle, that's the triangle. So call this triangle 1 and the area 1, again in counterclockwise direction, beginning with 3 comma negative 1. So the next is 2 comma 5 and the next negative 1 comma negative 4. Then back to the starting point 3 comma negative 1. So 1/2 of 3 times 5, 15. 2 times negative 4, negative 8. Negative 1 times negative 1, positive 1. Minus quantity, negative 1 times 2, negative 2. 5 times negative 1, negative 5. Negative 4 times 3, negative 12. Negative 17, negative 19, positive 19, 20. 20 minus 8, 12. 12 plus 15, 27. 1/2 of 27, 13.5 square units. Then area 2, this area here, beginning with 3 comma negative 1. So next is 6 comma negative 2, then 2 comma 5. Then back to the starting point 3 comma negative 1. So area is 1/2 of quantity 3 times negative 2. So negative 6. 6 times 5, 30. 2 times negative 1, negative 2 minus quantity. Negative 1 times 6, negative 6. Negative 2 times 2, negative 4. 5 times 3, 15. 15 minus 4 minus 6 is positive 5. Positive 5, negative of positive 5, negative 5. Minus 2, negative 7, plus 30, 23. 23 minus 6, 17, and 1/2 of 17 is 8.5. To check, 13.5 plus 8.5 is 22 square units, so that checks. Therefore, centroid, remember, formula for centroid of area 1 is 1 of triangle is 1/3 of the sum of the x coordinates. So 1/3 of 3 plus 2 plus negative 1 is 4/3. Then y sub c1 is 1/3 of negative 1 plus 5 plus negative 4, and that is 0. So therefore centroid 1 of area 1, triangle 1, is 4/3, comma 0. X sub C2 is 1/3 of 3 plus 6 plus 2. So that's 11/3. And Y sub C2 is 1/3 of negative 1 plus negative 2 plus 5. And that is positive 2/3. So centroid 2 of this triangle 2 is at 11/3, comma 2/3. Then we apply Varignon's theorem. Area times x sub g, centroid of the entire region, is equal to area 1, which is 13.5, then x sub c1, 4/3, plus area 2, 8.5, then x sub c2, 11/3. Using your calculator there, x sub g is at, the centroid of the entire region is at 2.235 square units. Then 22 times yg equals area 1 times y sub cg1, which is 0, plus area 2, 8.5, then y sub cg2, 2/3. Using your calculator, it is 17/66. That's approximately 0.2576 in decimal. So the centroid of the entire region is at 2.235, comma 0.2576 to 4 significant figures. For the slope or the angle, the vertex angles, so this is the formula. Tangent theta equals slope of the terminal line minus slope of the initial line all over 1 plus slope of terminal, slope of initial. Then the slope, because we have here the distances, and for this line it is negative slope, it is inclined up to the left, so this is negative slope, negative 7/4. For this line, it has positive slope, it is delta y 9/3, so its slope is 3, m sub cd is 3, m sub bc, because this is negative slope, so negative 7/4, this is the slope, but it's negative. For this line, it is negative. For this line, the slope is positive. So 3/4, that's why 3/4, the slope of AB is positive 3/4. And for this line with negative slope, 1/3, so negative 1/3 is the slope of this line. MAB is negative 1/3. So if you use the formula, tangent theta A is equal to, so this is angle A, but we can compute theta A because if you use this formula, the angle calculated is always acute angle. So if extended, this is the terminal line, the slope of this is slope of AB, which is 3/4, and the initial line, because the angle measurement should be counterclockwise, so this should be the terminal, this is the initial, which is AB, and the slope is negative 1/3 all over 1 plus slope of terminal 3/4 times slope of initial line negative 1/3. So using your calculator, theta A is 55.30 degrees. So if that is theta A, this angle, total angle at A is 180 degrees, straight line angle is 180 degrees, then plus theta A, which is 55.3. So angle A therefore is 235.30 degrees. So that's angle A. Then another way to compute for angle A is we solve for these angles. So this is inverse tangent of 4/3, this angle here. Then in this angle is inverse tangent of 3/1. So you can compute this angle, treat the slopes positive because you're going to use your calculator. And the total angle here is 360 degrees minus this angle, inverse tangent of 4/3, minus this angle, inverse tangent of 3. And you will get the same answer of 235.3 degrees. Then for angle B, we have tangent So in counterclockwise direction, so this is the counterclockwise measurement. This is the terminal line, which is the slope is negative 1/3. This is the initial line with slope also negative 7/4. So using the formula, tangent of angle B equals terminal slope negative 1/3 minus initial slope negative 7/4 all over 1 plus negative 1/3, then negative 7/4. It will give us positive slope net. Then inverse tangent of that positive slope is 41.82 degrees, and that's angle B. Another way is the angles are presented here. Inverse tangent of 1/3, we don't mind the sign. Inverse tangent of 1/3 using the calculator is 18.435 degrees. Then inverse tangent of 4/7, you will get this angle 29.74 degrees. Then theta B is equal to 90 degrees minus 18.435, I just use 18.43 degrees here, minus 29.74, and you will get the same answer of 41.82 degrees. We then proceed to angle C. So in counterclockwise measurement, this should be the terminal line with slope negative 7/4. This is the initial line with slope 3. So tangent of C is terminal negative 7/4 minus initial positive 3, so minus 3 all over 1 plus negative 7/4 times 3. So the numerator is negative, the denominator is negative, so the net value here is positive. Using your calculator, inverse tangent of the angle here is 48.18 degrees. Another way is the practical way without memorizing this formula. You might not be able to memorize this formula, although the derivation of this is in the preceding videos, the starting video on angle formed between two lines. So inverse tangent, we just treat everything as positive. So 7 inverse tangent, the opposite 7/4 is 60.26 degrees, while inverse tangent of 9/3, which is inverse tangent of 3, is 71.57 degrees. So this angle is 180 degrees minus 60.26 degrees minus 71.57 degrees. I'm not presenting it here, but I'm just mentioning it. You will arrive at the same angle C of 48.18 degrees. Then finally, for angle D, in counterclockwise measurement, so this should be the terminal line with slope 3 and the initial line with slope positive 3/4. So tangent of D is terminal slope 3 minus initial slope 3/4 all over 1 plus terminal times initial, and this is positive. So inverse tangent of whatever is the result here using your calculator is 34.70 degrees. Then another way is angle D, inverse tangent of 3/4 is 36.87 degrees. Inverse tangent of 3/9 or inverse tangent of 1/3 is 18.43 degrees. Then this angle is 90 degrees minus 36.87 degrees minus 18.43 degrees, and you will arrive at the same angle 34.7 degrees. So that's it for this video.